At present, the position of the Moon is 384,000 km from the Earth, 238,855 miles away, but property studies have shown. About 320 million years ago, when the Earth's tectonic plates were just starting to move and the microorganisms living in the oceans started eating nitrogen. At that time the Moon was only 270,000 km from Earth, 170,000 miles away, which is about 70% of the current distance. Scientists have recently been able to measure with 100% accuracy exactly how fast the Moon is moving away from Earth by shining a laser beam onto reflectors placed on the back of the Moon by the astronauts of the Apollo missions. They confirm the Moon is moving away at a rate of 1.5 inches, 3.8 centimeters per year, and as a result the length of our days is increasing little by little. Today we will discuss why the Moon is moving away from our Earth. Hey guys, I am FT Raj, so let's start the video. David Waltham, a professor of geophysics at Royal Holloway University in London who studies the relationship between the Moon and the Earth, says this is due to the tides. Tidal pull slows Earth's rotation, and that force creates angular momentum on the Moon. Basically, as the Earth rotates in its orbit, the gravitational pull of the Moon, a little further away, creates tides in the ocean. These tides swell the ocean water, which expands in an ellipsoid shape, once towards the Moon's gravity and other times in the opposite direction. But because the Earth spins on its axis much faster than the Moon's orbit, friction with the ocean basins beneath the Moon works to hold that water in. This means that this upwelling of ocean water occurs slightly ahead of the Moon's orbit. The Moon then tries to pull it back, reducing our planet's spin even if only slightly. As the Moon gains momentum, Earth's rotation slows further, causing the Moon to move into a slightly higher orbit. According to the latest analysis, this progressive slowing of our planet's rotation means that day length on Earth has increased at an average rate of about 1.09 milliseconds per century since the late 1600s. Other measurements based on ancient observations of lunar eclipses put the number slightly higher, at a rate of 1.78 milliseconds per century. Although this may not seem like much, it represents a profound change in the 450 million years of Earth's history. The Moon is believed to have formed in or around the first 50 million years after the birth of the solar system. The most widely accepted theory is that when Earth was just forming, it collided with another Mars-sized object, known as Theia. This resulted in the separation of a part of the Earth, which we now call the Moon. What is now clear from geological data preserved in rock layers on Earth is, in the past, the Moon was much closer to Earth than it is today. Back then the Earth was spinning so fast that it shortened the length of the day, in 24 hours, with 2 sunrises and 2 sunsets, instead of 1 now, says geophysicist Tom Uhlenfeld of Friedrich Schiller University in Germany. This may have reduced the day-night temperature difference and affected the biochemistry of photosynthetic organisms. What his research and others have shown is that the rate of lunar recession has not always been the same. It has sometimes increased and sometimes decreased over time. According to a study by geologist Vanina Lopez de Azarevic of Argentina's National University of Salta, about 550 to 625 million years ago, the Moon retreated to 8 inches, 7 centimeters, a year. The speed at which the Moon moves away from Earth has changed over time and will continue to do so in the future, says Mr. Uhlenfeld. However, throughout most of its history the Moon moved away at a much slower rate than it does now. In fact, we are currently living in a period when the rate of this retreat, lunar recession, is unusually high. At this rate, the Moon would have had to wait only 1.5 billion years to reach its current position. But the process of lunar recession that has been occurring since the Moon was formed 4.5 billion years ago has clearly been much slower in the past. At the moment the tidal force is 3 times higher than it should be, said David Waltham of Royal Holloway University. The big reason behind this could be the size of the Atlantic Ocean. The way the Earth's continents are now positioned creates a shock in the North Atlantic Ocean basin, meaning that the water in this ocean moves forward and back once at a rate close to the tides. By example, Dr. Imagine a child being pushed on a swing, says Waltham. If each push is followed by another push at the same speed, the height of the swing will increase. That wouldn't have happened if the North Atlantic had been a little bit wider or narrower, he says. The models we've built show that if you go back a few million years, the tidal forces were also very low because the continents were positioned differently. But this is likely to change in the future. Modeling predicts that a new tidal resonance will emerge 150 million years from now and then dissipate when a new supercontinent forms on Earth about 250 million years from now. So, could we eventually see a future where there are no moons around Earth? Even with such a high rate of drift away from Earth at present, it is unlikely that the moon will leave Earth completely. In about 5 billion to 1,000 billion years, the sun will likely die a catastrophic death, but long before that, human civilization will likely be extinct. However, in the short term, human civilization itself can play a role in reducing day length by reducing the amount of water trapped in glaciers and ice caps due to climate change. The ice essentially suppresses the tides, notes Dr. Waltham, noting that about 600 to 900 million years ago, when our planet entered a special frozen age known as a snowball or snow-covered Earth, the rate at which the moon moved was dramatically slower. In theory, when the next group of astronauts from NASA's Artemis program fly to the moon, they will be able to say that they have looked back at Earth from a greater distance than their predecessors in the Apollo program did 60 years ago. Although this will depend on which point in the moon's elliptical orbit around Earth they arrive at, as the distance between its closest and farthest points varies by 43,000 kilometers every 29 days. But for those of us now on Earth, life is so short that a picosecond is added to the length of each day, and if you blink, you'll miss it. Hundreds of billions of years ago, average day length on Earth was less than 13 hours, and now it is increasing. The main reason behind this is the relationship between the moon and our oceans. The moon's presence on Earth has been an integral, and somewhat haunting, presence throughout human history. Its gentle gravitational pull dictates the Earth's tidal rhythms, and its pale light prompts many species of nocturnal animals to engage in sexual activity. All the civilizations that have come so far in the world have made their calendars or almanacs based on Shukla and Krishna Paksh. And some animals, such as dung beetles, navigate at night using sunlight reflected off the back of the moon. More importantly, according to some theories, the moon helped create the conditions that made life possible on our planet, and even the moon helped start life on Earth in the very beginning. The moon's eccentric orbit around our planet is believed to have played a role in creating some of the most important weather systems that continue to affect our lives to this day.